Hello and welcome you all once again to Maths by Gurpreet Sekho. So far we've been doing differentiability of 12th standard, that is 5th chapter in NCERT Maths, and we had completed 5.3 in our previous video. So now we'll be starting exercise 5.4. Exercise 5.4 is very easy. There are only two functions which are going to be differentiated in this exercise. First one is logarithmic function, and the second one is exponential function. Logarithmic function, for example, log of x. If we want to differentiate log of x with respect to x, then we will get the differentiation as 1 upon x, and then this x will be again derivated d upon dx of x, and dx of x is 1, so ultimately we'll get 1 upon x as our answer. So log x, derivation of log x with respect to x is 1 upon x. What about the exponent? For example, e raised to power x, we are going to differentiate it with respect to x. You will get e raised to power x is itself, and the power will again be differentiated with respect to x. So x will be differentiated with respect to x again. You will get e raised to power x ultimately. So you have to remember these results as such. The derivation of log x with respect to x is 1 upon x, whereas the derivative of e raised to power x with respect to x is e raised to power x itself. So we are done with the introduction of logarithmic as well as exponential function. So without wasting any time, let's start with the exercise, and there is only one example in which there are 4 subparts, the example number 29. And we have to differentiate the first part, that is e raised to power minus of x with respect to x. So let's do it. It's very easy. Differentiation of e raised to power minus x with respect to x will be, of course, the exponent itself, e raised to power minus x itself, and then this minus x will be differentiated with respect to x separately, clear, as we have done in the introduction part. So minus x, derivation of minus x with respect to x is minus 1, of course. So e raised to power x will be multiplied by minus 1, or we will get minus of e raised to power minus x, clear. Next part that is given in the same example is sine of log of x. So in the angle of this trigonometric function, that is sine, the angle is log x. So now we'll be applying the formula of derivation of sine x with respect to x firstly, and then we'll be differentiating log x, and then we'll differentiating the x. So firstly we have to differentiate sine of log of x with respect to x. So sine theta, the derivation of sine theta is cos theta. Okay. Cos of theta. What's theta in this case? Log x. Now it will again be differentiated with respect to x because it was the angle of sine. So log x will be again differentiated with respect to x. Cos of log x will remain as it is. What will be the differentiation of log x? We have studied, that is 1 upon x. So your answer will be cos of log x upon x. Clear? Let's move to the third part, that is cos of inverse of e raised to power x. Now it's again trigonometric function, but this one is the inverse trigonometric function. So we'll be applying the formula of inverse trigonometric function, and we'll find the differentiation of cos of inverse. Firstly, let's try it. Cos inverse of e raised to power x, in the angle there is e raised to power x. Now we'll be applying the identity of cos, the differentiation of cos inverse x or cos inverse theta. So cos inverse theta, the angle is e raised to power x, and what's the differentiation of cos inverse x? That is minus 1 upon under root 1 minus x square. What's x? That is the angle. In this case the angle is e raised to power x, so e raised to power x square. Don't forget to use brackets from place to place. Now this x will be again differentiated with respect to x. Clear? So it will remain as it is. Minus 1 upon under root 1 minus e raised to power x square will become e raised to power 2x. And e raised to power x, the differentiation of e raised to power x with respect to x is e raised to power x. So as an answer, you will get minus of e raised to power x upon under root 1 minus e raised to power 2x. Clear? I hope you are clear with these sums, because these are very easy. Actually, you only have to just apply the identity that we have learned, or the trigonometric that are very basic ones. That is why they are given in the previous exercises, so that once you will learn the identities and differentiation of inverse as well as the normal trigonometric functions, you will be able to apply them. Now the last sum in this part is we have to differentiate e raised to power cos x. Okay, so e raised to power cos x, firstly we will write it like this: e raised to power cos x with respect to x. Now it's e raised to power x, we'll consider it as e raised to power x. The differentiation of e raised to power x is e raised to power x itself, and cos x is at the place of x in this sum. This will be again differentiated with respect to x, that is cos x, and e raised to power cos x. And what's the differentiation of cos x? Yes, you know, just run your mind. Cos x, that is minus of sin x, and as an answer you will get minus of sin x e raised to power cos x. Okay, this would be the answer. Now there are one or two identities that are related with the logarithmic function. Let me tell you. If there is written log mn, like in the bracket there is the multiplication of two functions, then the log gets splitted into log m plus log n. Okay, and if there is log m upon n, then it again gets splitted as log m minus of log n. Clear? And if, for example, log m square, in the bracket there is some power of the function, then this power will come in front of the log. This will become 2 log m. Okay, so any power can be generalized and will come in front of the log. So 2 log m will be the identity. If we want to generalize it, log m raised to power n as an identity, we will get n log of m. So these are some of the logarithmic identities which are really useful, and with these 4 parts our exercise 5.4 examples are finished, and I hope that now you will be able to complete the exercise yourself, because it's very easy. Still, if you find any doubt regarding any sum, any identity, feel free to post in the comment section and I'll be more than happy to solve your problems. So I hope that you have subscribed my channel till now, but if you have not, so please don't forget to press the subscribe button as well as the bell icon in order to get updates regarding your chapters and regarding your mathematics syllabus. Thanks for watching and keep practicing.